Good morning. In our previous sessions, we discussed conductometric estimation, potentiometric estimations, and we have seen how to determine the amount of substance present by measuring conductance and potential of the reaction mixture. So today, the new method, colorimetry. What do you understand by colorimetry? Colorimetry. Colorimetry means measurement of color. Color is color, metry means measurement. So colorimetry means measurement of color. So today, by measuring the color, we can estimate the amount of the substance, chemical substance present in a given unknown solution. So this type of experiment or can be done for substances which are already colored or which gives color when a coloring agent is added. So this chemical analysis of this can be done when it emits color only in visible region, that is from 400 to 700 nanometer. So let us see the principle behind this. The colorimeter mainly depends upon Beer-Lambert's law. So Beer and Lambert's both were working separately on light, the intensity of light, and the how does it affect on the substances if they vary the intensity of the light. So Beer proposed a law which states that the intensity of the transmitted light decreases as the concentration of the absorbing substance increases. Similarly, Lambert's proposed this law which states that the intensity of the transmitted light decreases with thickness of the absorbing medium. So in both the law, one thing is common, the intensity of the transmitted light. So both the laws were combined together, which is called as Beer-Lambert's law, which states that the intensity of the transmitted light decreases as the concentration and thickness of the medium increases. So what do you mean by concentration? The concentration of the solution, concentration of the substance, maybe concentration of copper, concentration of iron, concentration of nickel, concentration of magnesium. As the concentration varies from 2 milligram to 4 milligram for 5, 6, 8, then intensity of the transmitted light also will vary. Why? Because if the concentration is 2 mg, then the light absorbed will be less, then transmitted will be more. As the concentration increases, absorbance will also increase. The metal ions only will absorb the light and the transmitted light will be less. If the metal ion concentration is less, then light absorbed will be less, transmitted light will be more, intensity of transmitted light will be more. If the metal ion concentration is more, then light absorbed will be more, then light transmitted will be, intensity of light transmitted will be less. That's what it means. And the thickness of the medium. What do you mean by thickness? Thickness is nothing but the distance between the object and the light emitted. So if the light is emitted from here, and here it is the object is placed, the distance from here to here is called as the thickness of the medium. So this is the source of the light and the object being placed. So the distance between these both is called as thickness. So the Beer-Lambert's law mathematically can be represented as A is directly proportional to C and T. So in order to remove the proportionality constant, A equals epsilon into concentration into T. So now if you want to measure the concentration, we're supposed to make thickness constant. That is, this is the emission, this is the source of light, and this is the where we are going to keep the sample. So we cannot change this. If you move this, what will happen? The transmitted light also will change. What would we do? The source of light and this sample holder, the distance between these both was kept constant. Therefore, absorbance is directly proportional only to constant when we keep this thickness of the medium constant. So now the colorimeter mainly designed only on the principle absorbance is directly proportional to concentration of the species, keeping thickness of the medium constant or the path length as constant. So thus, what are the advantages or the applications of this colorimetric estimations? So it gives more results, accurate results when the sample is very low. When the sample concentration is in ppm level or ppb level, we get very accurate results. So than the titrometric or gravimetric, classical titrometric or gravimetric method. So used to estimate metals, especially for metals which are colored like copper, iron, nickel, or which gives color when you add some complexing agents. So let us see the application of this. So colorimetric estimation of copper. So colorimetric estimation of copper, how it is done? So we want colorimeter cuvette. So colorimeter is an instrument to measure the absorbent. Cuvette, a small pipette, is called as a small test tube like thing is called as a cuvette, and filter, which filters only the light required wavelength, that is 620 nanometer, and burette to keep copper sulfate, ammonia and water. So why the grating is required? So 400 to 700 nanometer is the visible light, right? So each and copper will have a maximum wavelength. It will absorb maximum only at 620 nanometer, whereas nickel different and iron different. So in order to get one wavelength monochromatic light, you're going to use the grating or filter. When light enters, passes through that grating, which is fixed at 620 nanometer. So when it comes out of that, you get a monochromatic light of single wavelength. So without that, if this is source of light, it emits from 400 to 700 nanometer before passing through the grating. So it passes through the grating, and whatever light comes out here, it is monochromatized light. Monochromatized light means of single wavelength. Why single wavelength? Because as I told you, copper gives maximum absorption at 620 nanometer. So what is the procedure? So we'll have five standard flasks named blank, 5, 10, 15, 20 and 25. That is 6 standard flasks. Along with that, you will have one test solution. For each one of them, so named blank, you are going to add 0 ml of copper sulfate. The test standard flask named 5, you are going to add 5 ml, 10 ml. So similarly, up to 25, you are going to add 25 ml of copper sulfate. From blank to test solution, you are going to give unknown volume of copper sulfate solution. You are going to add equally 5 ml of ammonia. From blank test tube, about a standard flask named blank, 5, 10, 15, 20, 25 and a standard flask named test solution, we are going to add equally 5 ml of ammonia. So as soon as you add ammonia, depending upon the concentration, the color will change. So copper sulfate reacts with ammonia and it forms a complex cup ammonium sulfate. So remaining standard flask will be filled with water up to the mark. You're going to fill it with what water? Distilled water, and shake it. So now we're going to take the cuvette. Okay, so after diluting it up to the mark, we're going to take the cuvette, clean it. Okay, we're going to take water in the blank solution. So blank solution is nothing but it contains only water and ammonia. It does not contain any sample. Okay, so anything except you're going to add a blank solution is a substance or a solution. It contains all the chemical reagents except the sample. So anywhere blank means it contains all chemical reagents except the sample is called as blank. So we're going to take the blank. Okay, so we're going to take in the cuvette, wipe both the outside of the cuvette with tissue paper, keep in the sample holder and set the grating to 620 nanometer. Once you set the grating to 620 nanometer, using the set absorb knob, you are going to set the absorbance to 0. Why? Because it does not contain any copper, right? Any metal. Therefore, it is 0. Then we are going to remove that, throw it, then take 5 ml, keep it, measure the reading. Then take 10 ml, keep it in the colorimeter, take the reading. Then take 15, 20, 25 and test solution and take the absorbance reading and note it down. So at 620 nanometer. So now plot a graph of absorbance against volume of copper sulfate and determine the volume of copper sulfate and copper present in the test solution. When you plot a graph of copper sulfate absorbance against volume of copper sulfate, the nature of graph will be like this. So you're going to get, so only in copper sulfate, and the remaining thing, potentiometry you saw and conductometry you saw, so none of the graphs started from 0 because the blank value was never 0. Right, you used to take 0 reading, but 0 reading is not be 0. But here, for 0 volume of copper sulfate, the reading is also 0. Therefore, in colorimeter, the graph should start from 0 itself, and it is mandatory. For 5 ml, for 0, the reading absorbance is 0. For 5, you have some reading. For 10, you have some reading. For 15, you have some reading. For 20, you have some reading. 25, you have some reading. So, we're going to get some straight line passing through the origin. Right. So, now for test solution, you know the absorbance, but you don't know the volume. You don't know the volume of copper sulfate. You're going to search for the absorbance on the y-axis. Okay, then once you get that, you're going to draw a parallel line to x-axis until it touches the curve. Once it touches the curve, you're going to drop a perpendicular to x-axis. So whatever volume you get there, that is the volume of copper sulfate present in the test solution. So similarly, you can carry out for different metals, maybe nickel, iron, manganese. So whichever metal gives you color, or whichever substance metal gives color by adding complexing agent, can be done, estimated using this colorimetric estimation. So colorimetric can be done only for substances which gives color or it's already colored. Thank you. In the next section, we are going to discuss about flame photometry. Thank you.